everybody. So today we will finish 9.4, okay? And then you can start working on homework 7. And the next exam is about 9.3 to 9.6. We will see whether we need to postpone the exam 3. Okay, so yeah, we will see. Today our goal is to finish 9.4. So, by the way, if you missed some class last week, make sure you watch the recording and take notes. Because I said 9.3, 9.4 are hard. And you can see the example. It takes 15 to 30 minutes for one example. And yeah, so it is hard. Okay. So the idea of the 9.4 is we have a surface, and that's the f function. And we have the constraint. It's usually the g. G is a function on the xy plane. So okay, maybe I should like show you the picture here, right? So we have the surface. The constraint is like this little green line or curve on the xy plane. Then you cut the surface, you get a curve. And the Lagrange multiplier helps us to find the maximum or minimum. Okay. And the system is, so this is the Lagrange multiplier. The system of equation, you have the gradient of f equals the lambda times the gradient of g. And then we also have the constraint, g equals to 0. Again, if you missed some class, watch the recording. And yeah, if you have questions, feel free to ask me. And there are so many different ways to solve a system. Last time we did the first example. Yeah, there's a lot of algebra. And then after this, I show you another way, which is in the class notes on the website, where we use a different method. We use equation 1 divided by equation 2 to eliminate the lambda, and then we figure out that method is easier. So today, let's do more examples. Okay, so suppose we want to find the maximum and minimum value of the function. So the function is like the surface, y minus x squared. So this is the surface. Okay, this is a surface in R3. On the circle, x squared plus y squared equals 1. Okay, so this is the constraint. Can you see this is the constraint x squared plus y squared equals 1? And you can draw the level curves of the surface. So you get a bunch of the paragraphs. This is the level curve. And this level curve, the z, the height, is 1.5. This level curve, the z is 1, and then here 0.5. And can you imagine the picture? Maybe it's good to draw the picture of the surface. So sometimes it's good to like understand what the surface look like. So what is that? Y minus x squared. So z equals y minus x squared. Can you imagine? This is the surface. Okay? And our constraint is like a circle right there. Can you see the circle? It kind of cut the surface. Okay, let me see if I can print screen. Then I can draw on. Let's open a new file and draw here. So the constraint is the unit circle x squared plus y squared equals 1. Can you imagine? And you use this constraint to cut the surface. Oh, what do you get? So you probably get like this point and like this point. You kind of get a curve. Can you imagine? You kind of cut it and you kind of get a curve. So this curve, you can find the maximum and and you can find the minimum. All right, so this is what we are doing. And thank you. Oh, hi. And if you want to draw the level curves, so you see level curves is a lot of plane, horizontal plane, and you color. You see the level curves is a lot of parabola, right? That's why on this picture, you see a lot of parabola of different heights. And okay, let's answer the following questions. Are there any points on the constraint at f of xy equals -1? -1 is here. Do we have a point? Yes. Yes, which is this point. Okay. Are there any points on the constraint where f is -1.5? No, you see, -1.5, no intersection. So no. Are there any point on the constraint f of xy is less than -1? Ooh, today we have a new sheet. Yeah. Okay. So less than -1. Yeah, a lot of them less than -1. Right? And let's see. These points are less than -1. Right? This side is more negative, this side is more positive. So these parts is less than -1. Yes. Which is this part and this part less than -1. Label in the figure to the left the approximate location where f attains its maximums and minimum on the constraint. So let's label the maximum. I would say this is the max. Do you agree? Yeah, because that direction is more bigger values. That's the max. And the smallest, I would say, because this is -1, you want to go to this direction will be like smaller, right? So I would say like probably this point and this point will be the minimum. Do you agree? About like that. Okay. Oh, sorry. They should be symmetric. Okay, like here. Yes. And then, what happened on those points? Can you see here? Last time we talked about the gradient is perpendicular to the level curves. Okay, level curve. Therefore, at the maximum or minimum, you can see the gradient of f and the gradient of g. They are parallel. Like here, the gradient of f and gradient of g, they are parallel. That's why we have the Lagrange system. Okay, we have the gradient of f is parallel to gradient of g. It means it's a scalar multiple of the gradient of g. So this is the vector, okay, multiple. And we also have the points being on the constraint. That's why the points satisfy the constraint. The g of xy equals to 1. And now let's solve the system. Okay, so we have those two systems. Now how do we solve it? Yes, so this is called the method of Lagrange multiplier. We'll compute the gradient of f is the vector fx comma fy. And what was the f? Y minus x squared. Okay. Do you still remember in 9.3? In 9.3, we have a surface. We compute the maximum and minimum of the surface. And what we did is we compute the first partial derivative, we set it equal to 0. That's the critical point, right? And then we need the second partial derivative to compute the d. And d is fxx, fyy minus fxy squared, right? recommend you to take a look at the concept maps. Okay, so because concept map help you to see the connection between multiple sessions, and you can also compare them, right? So 9.3, you still have the concept map review? No? 9.3, we have a surface, we find the maximum minimum. So we find the critical points. So you have a system of two equations, because you only have two unknowns, x and y. So system of two equations, and you solve the system. And at those points, you need to compute the second partial derivative and compute the d to see whether it's local mass or local mass. Do you remember that? But Lagrange multiplier, do you need the second derivative? No, only the first partial derivative. Okay, and you're doing this system. So they're like the different system. You don't set fx or fy equal to 0. Okay, you don't set it equal to 0. You set gradient of f equals lambda times gradient of g, and also the constraint. Okay, so what is partial f partial x? Derivative of y is derivative with respect to x, 0. And derivative of negative x squared? Yeah, negative 2x. Okay. How about partial f partial y? Derivative of y is 1. Derivative of x squared? 0. Yeah, y. Y is the variable, x is the unknown. So we get 1. Right, everybody? And so this is the partial the gradient of f. Now the gradient of g is dx gy, and our g is x squared plus y squared minus 1. So the constraint usually is a equation. You use the left-hand side minus the right-hand side of the constraint. Okay? And so now what is the derivative with respect to x? 2x. And then the y squared minus 1 derivative with respect to x is 0. Yes. So we have 2x. How about the derivative with respect to y? 2y. Okay, so this is the gradient vector. Now we set up the system. Gradient f equals lambda, gradient of g, and g equal to 0. This is, look at the gradient of f. This is a vector equation. It means the first component on the left-hand side is lambda times the first component of the gradient of g. So negative 2x equals lambda times 2x. Is that okay, everybody? Yeah, this is a vector component. And then we have also the y. The y component, we have the 1 is lambda times what? 2y. Yes, everybody? And then we also have the constraint. The x squared plus y squared minus 1 is 0. So this is a system, a nonlinear equation. And we have 3 unknowns. We want to find x and we want to find. Okay. And let's label them. So 1, 2, 3. 2 methods. Okay, so solving system of equations. So 2 methods. Either like substitution method, or you move all the terms on one side and you factor them. Okay, And let's look at these. I would say look at equation 1. We can move all the terms on one side and factor. And when you solve a system of nonlinear equations, be careful. You never divide it by a variable. You can divide it both sides by a constant, but don't divide it by a variable because you will lose some solution. Okay, so let's look at number 1. Okay, move all the terms on one side. Okay, so let's see. I will move the 2x from the left to the right. So I get lambda times 2x plus 2x equals 0. Okay, so we add 2x on both sides. Then we get lambda times 2x plus 2x equal to 0. Is that okay, everybody? And now we want to factor. What can we factor? What can we factor? The common factor is 2x, right? If we factor out the 2x, what's left? Lambda plus 1. Yes. Do you see we have a product of two factors equals 0? Yes, so this is the trick. You move all the terms on one side, you factor. If you see a product of two factors equal to 0, you say either the first factor is 0 or the second factor is 0. So you break into cases. Okay, let's see. So we get either the 2x is 0 or the lambda plus 1 is 0. Therefore, we get x equal to 0 or the lambda equals -1. Because it's or, it's not and, that's why you separate into the cases. So, case 1, if the x is 0. Okay. So far, so good, everybody? Because you have or, it's separate into two cases. It's one of them could happen. You don't require both of them happen. One of them happen. If x is 0, look at the last equation. We can then plug in the third equation. What do we get? X is 0. So 0 plus y squared minus 1 is 0. Let's do. Okay, everybody? Yeah. Why don't we plug in the second equation? Do you have an x in the second equation? No. That's why we plug in the third one. Yeah. All right. Oh, do you see we get y squared equals 1? When you solve for y, what do you get? Plus or minus square root of 1. Yeah, when you take square root, you get plus or minus. Therefore, we get 2 points. So we get 0, 1, and we also get 0, -1. We have two solutions in this case. Are so good? Yes. And now case 2. If what? Lambda is -1. Right? That's case 2. When the lambda is -1. And then which one do we plug in? Equation 2 or equation 3? The 2. The 2 has the lambda. The 3 does not have any lambda. Right? So we plug in equation 2. We get 1 equals lambda is -1. So -1 times 2y. Oh, what is y? Do we add 2 or divide it by -2? Divide. So y equals negative. You divided both sides by -2, right? This is multiplication. 1 equals -2y. So both sides divided by -2. We get y is -1/2. Right? Everybody? Okay. Yes, by the way, this process is long. It needs a lot of algebra. So, yeah, more practice. And yeah, come to see me in my office hours. Make sure you understand every problem in the in-class notes and homework. Okay, so that's the y. And then we know the y, we can then plug in the third equation and find the x. Let's see, plug in the third equation. X squared stays here. But what happened to the y squared? What is -1/2 square? Yes, just 1/4. Is everybody okay? And then we also have subtract 1 is 0. Yeah, x squared, y squared is 1/4, and subtract 1 is 0. What is 1/4 minus 1? Yeah, -3/4. If we move this to the other side, we get 3/4. Right? And oh, what happened? When you take square root, you get plus or minus, right? Square root of 3/4. Oh, square root of 3. What is square root of 4? 2. Yes, everybody? So we get the x. Square root of 3/2. The y is -1/2. And the other point, the x is negative square root of 3/2. And the y is also -1/2. So in this case, we also have 2 points. Right, everybody? Okay, so after we solving the nonlinear equations, we get our solution. And then the method of Lagrange multiplier says all the maximum and minimum happens there. So what do? You put this into your surface and see which one has the bigger f. The bigger f will be the maximum value. The smaller f will be the minimum value. Okay, everybody? I don't have enough space. So do you still have enough space? Okay, good. If you don't, you can use a scratch paper and then write on your scratch paper. Okay, and I can shrink it so I can have more space here. All right, so we have 4 points. We plug in. Okay, let's plug in. See? All right, so make it bigger. Okay. See, the problem is so long, even though my word need to process. Okay. All right. So, come on. Okay, we plug in the first point into our app. So, yeah, could you plug it in your app and figure out what values is that? Okay, I think my word. Okay, is not responding. So maybe let me close this one. Don't save that one. Whoa, that would take a long time. Maybe it works. Oh, okay, it works now. Okay, so all right, f of the first point is 0, 1, right? And we plug in the f. So this is the f. We plug in here. Y is 1, x is 0, right, everybody? And we get 1. Okay, the other point is what? 0, -1. The y is -1. The x is 0. Oh, do you see we get -1? And the next point is what? Square root of 3 over 2 and -1/2. We plug in it. The y is -1/2. The x is root 3 over 2, but square. So what is square? 3 over 4. 8. How do we get the common denominator? That's all right. We multiply by 2 and multiply by 2. Yes. So we get -2/4 minus 3/4. What is that? Negative. Yeah, very good. Right, everybody? So the last point, root 3 over 2, but negative, and the y is -1/2. Do you see what happened? When you plug in. Yeah, exactly, same number. So we get -5/4. Okay, among those 4 points, which one is the biggest? The 1. So this is the maximum value. Which one is the smallest? Yeah, so both of them are minimum values. Okay, everybody? Keep that in mind. Let's look at our picture. Do you see the maximum? Yeah, the maximum is at 1. Yeah, it matched. And the coordinate is 0, 1. Yeah. And the minimum, we have 2 of them. The y coordinate is like -1, and then the x coordinate, one is positive, one is negative. And -5/4, yeah, it's less than -1 and bigger than -1.5. So our answer match with the graph. Okay, so this is the method of Lagrange multiplier. Compute the gradient of f, compute the gradient of g, but don't set them equal to 0. Okay, you're doing the system gradient of f equals lambda times gradient of g. And then because the point is on the constraint, we have g equal to 0. And you solve the system, and then you plug the solutions into the f to find the maximum and minimum values. Another question is, if you only have 1 point, then how do you know this is a max or min? Pick any other point in the constraint and plug in f to see if that number is bigger than your solution or smaller, to see whether it's a max or min. Okay, let's look at the next example. All right, so yes, let's see the next example. We have the f is x squared plus y squared. The picture will look like a paraboloid. Okay, this is like the paraboloid. The x squared plus y squared is like parabola. So it's like it's in 3-dimensional space. Is a paraboloid. And then this is a line. Do you agree? A line. So I don't know what the line look like. I just estimate. Okay, so you use this line and then you try to cut it. guess what? You will see something like that. So I would say there is a minimum. Right, everybody? Yeah, so let's find that. Gradient of f. Yeah, by the way, we do spend like 20 minutes on one example. So my goal is to finish these two examples so we can finish 9.4 today. Okay, gradient of f. So fx, fy, the first partial derivatives. What is fx? What's the derivative with respect to x? 2x. Yes, everybody? What's gradient with respect to y? 2y. Okay, good. And now g. So we define the g to be the left-hand side minus the right-hand side. So I would put y plus 2x minus 3. Is that okay, everybody? So gradient of g is gx and gy, the partial derivatives. What's the derivative with respect to x? What is the derivative with respect to x? 2x? Just 2. Yes. Just 2. And how about the derivative with respect to y? 1. Is everybody okay with that? Alright, system. Gradient of f is lambda times gradient of g. And also g is 0 because it's on the constraint. This becomes, so this is a vector equation. We look at each component respectively. The first component, it tells us what? What does the first component tell us? 2x equals lambda times 2. Yes. So 2x is lambda times 2. Right? That is the first component. How about the second component? Yes. And then the g is y plus 2x equals 3. So you can put like y plus 2x minus 3 equal to 0. But you know it's the same as y plus 2x equals 3. Is that okay, everybody? All right. 2 methods. Either substitution. You express x in terms of lambda, express y in terms of lambda, and then plug in here. This is one method. The other method is eliminate the lambda. You can use equation 1 over equation 2 to get rid of the lambda. And then you can express, you get a relation between x and y. Okay? So I would think eliminate the lambda is easier. Yeah. So use equation 1 over equation 2. On your left-hand side, you see the 2x over the 2y. On the right-hand side, we get lambda times 2 over lambda times 1 is lambda. Yep, everybody? Do you see the 2 cancel? Do you see the lambda cancel? And this is the same as a cross multiply. You have x is 2y. Are you okay with cross multiply? So x times 1 is 2 times y. So we get x equals 2y. Great. We can then plug in equation 3. Everybody? We're going to plug in equation 3. Oh, you can do that, or you can like replace x by 2y. So you have y plus 2 times 2y is 3. Yes. So y plus 2 times 2y equals 3. And then, ooh, what is 2 times 2? 4y. Ooh, what is y plus 4y? 5y. See, don't move the x to the other side because it has the y. Then you can combine the y on the left. Oh, what is y? 3 over 5. Good. What is the x? 2 times y, which is 6 over 5. Oh, our point is what? 6 over 5, and then the y is 3 over 5. Yes, everybody? We only have one solution in this case. So we can plug in the f. So we plug in the f. And we get x. X squared is 6 over 5 squared. Plus y squared is 3 over 5 squared. And then what is 6 squared? 36. 5 squared? 25. 3 squared? So what is 36 plus 9? 45. Ooh. Can you cancel the common factor? So you get 9 over 5. Right? We get one number, one solution, and we get a f value. But how do we know it's max or mean? Bless you. From the picture, yes, it probably is the mean. But to confirm that, okay, because unlike the previous examples, you have multiple solutions. You can plug in f and see whether it's positive or negative to determine whether it's a max or min. But here you only have one point. Then you pick another point in the constraint. Okay, the constraint y equals 2, y plus 2x equals 3. You pick any other point on the constraint. Usually, we let x as 0 because that is easier. If you let x as 0, what is your y? Y is... If you let x as 0, y is 3. So we find the point 0, comma 3. Right, everybody? Now you plug in the f. So f is x squared plus y squared. X squared, so it's 0 squared. The y is 3 squared. What's your answer? 9. Do you see 9 is bigger than 9/5? Yes. So f has a minimum at the point 6/5. This is actually a minimum value. Okay? And match with our answer. This is what you do. If you only get one point, you have no other point to compare. Then you pick another point from the constraint. And usually you either take like x is 0 or y is 0. That's easier to compute. And then you get a number to compare with this number. Oh, this is smaller, so it's a minimum value. And it makes sense with our picture. Is that okay, everybody? And you can see this problem, the process is easier because you don't have a separate cases and you only have 1 point instead of multiple points. Okay? All right, this is one example. We have 6 minutes left. Is it okay I go over the notes with answer with you and talk about the idea? Yeah. Okay. So thank you for your understanding. I wish I could have more time for this course, and I think we need that. And then we can go over more examples in detail. But in this case, we cannot. Okay, so this is the application problem. You have a similar problem in your homework. Okay, so a manufacturing firm estimates its cost production of automobile batteries in thousands of units. Is the following, where X is the number of units of labor. Yeah, so don't need to take notes right now. So everybody will try to understand it, and you can do the notes after class. So X is the number of units of labor, Y is the number of units of capital utilized. Labor costs are $80 per unit, and capital costs are $150 per unit. How many units each of the labor and capital will maximize the production if the firm can only spend $40,000 for this cost? So this is the function f. That's the surface. We have a constraint. We have a fixed amount of money we can spend. So the cost is x is the unit of labor, and it costs $80, right? So x times 80 plus the y is the unit of the capital. It costs $150, and we add them together. We want to have this cost equals to 40,000, right? So this is the constraint. We have the function f in the constraint. So now the g, we use the left-hand side minus the right-hand side, okay? And the fx, okay, this is a product, but you don't need product rule because every time you do one, x is a variable, the y is a constant, right? So the derivative with respect to x is 3 times 1/3 x to the minus 2/3. And then the y just copy it because it's a constant multiple. No need product rule. And therefore 3 cancel. We have x to the negative 2/3, y to the 2/3. And then fy. Okay, fy, the 3x, that constant multiple stays here. And then the 2/3 moving in front and y to the negative 1/3. Do you see 3 cancel? We get 2x to the 1/3, y to the negative 1/3. That is the gradient. The g, look at this. Derivative with respect to x, 80. Derivative with respect to y, 150. Okay? And then the system. The first component of the gradient of f equals lambda times 80, right? And then the y equals lambda times 150. And we also have the constraint. Right, everybody? This is the system. How do we solve the system? It's one trick. Eliminate the lambda. So you use equation. I use equation 2 over equation 1 because the number, the equation 2 is bigger number than the equation 1. So I don't get many fractions. But, yeah, look at the x. You know x to the a over x to the b is x to the a minus b. Therefore, when you combine the x, you get x to the 1/3 minus negative 2/3, which is 1/3 plus 2/3, which is 1. Is that okay, everybody? And here, look at the y. This is y to the negative 1/3 and minus 2/3, right? So it's y to the negative 1. It means the y is in the denominator. And then we cross multiply. We get what? 15y is 2 times 8, 16x. And you can solve for y in terms of x. both sides divided by 15. Then plug in the third equation. Then you plug in the third equation. 15y. Oh, 15y. No need to divide by 15. It's 16x. 8x plus 16x is 24x. And so x is 4,000 over 24. And then the y is what? 16x over 15. And x is 500 over 3. So you cancel, you get 1600 over 9. You get one solution. Okay, you get one solution. So you plug in f, and you get this is the f values. But how do you know it's a maximum or minimum? Like the previous problem, find a point in the constraint. So find a point in the constraint and plug in f and compare with that point. What I did, I plug in y is 0, and then I find the x, and I plug in the f. You see, if one of them is 0, your f is 0. So this number is smaller than that. So this is at maximum. Okay, so you can see the idea is similar to the previous example, but because the function is harder, and also it's a real life story, so the number is bigger. But the idea is similar. Okay, if you get one solution, you find a point on the constraint. Usually you take x is 0 or y is 0. Okay? Yes. Okay, 10:50. Good. Have a nice day. Next class, pre-now 9.5 worksheets. Okay. Yes. Have a nice day. Yeah, keep working on your homework. Ask me more questions. I hope you can get 100% for the homework.